For many institutions, generative AI looks like a high-speed administrative shortcut. The assumption is that it's a tool built for generating text faster or stamping out grades on an assembly line of identical student documents. But that view misses the actual utility of the technology. The integration of generative AI marks an architectural transition. It forces education away from the static, batch processing of students and toward dynamic, multivariable adaptation. This timeline tracks artificial intelligence from 1970s rule-based systems through 2010's deep learning breakthroughs. By the 2020s, generative models broke the constraints of fixed programming, synthesizing new data based on patterns rather than just retrieving existing information. Viewing a synthesis engine as a glorified digital grading tool severely restricts an institution's ability to adapt. Surviving the transition to modern learning requires leveraging these models to reconstruct the entire educational process. This generative AI pedagogy stack is a 5-pillar framework mapping the reconstructed learning experience. Operating sequentially, it moves from ingesting personalized data at the base layer through adaptive assessment, ultimately cultivating social-emotional intelligence and lifelong career skills. Historically, education systems fail to scale individualized instruction because human instructors cannot simultaneously write custom curricula for 30 different proficiency levels. This systemic approach resolves that bottleneck by automating the customization process in real time. Implementing this complete stack rewires the student data loop. The curriculum responds to the learner's needs, reversing the traditional dynamic where the student must conform to a fixed static curriculum. Differentiated instruction involves creating varied learning activities to cater to different student needs. But it has always hit a hard physical limit, the cognitive bandwidth of a single human teacher. One educator simply cannot process the real-time learning metrics of an entire classroom simultaneously. This diagram illustrates how generative AI bypasses that physical limit. The central personalized learning hub processes 8 disparate data streams simultaneously. By actively weighing non-academic inputs like cultural background alongside social and emotional needs, the system dynamically routes content for every specific student. True personalization depends entirely on high-velocity data ingestion. While curriculum design is important, the success of this model rests on the system's ability to act upon thousands of micrometrics in real time. Traditional formative assessment relies on a built-in delay between completion and correction. Real-time assessment adaptation replaces that linear sequence with an immediate feedback cycle, processing a student's input to calibrate the very next task. If a student struggles with a specific concept, the system detects the friction point and initiates a targeted intervention. It instantly deploys scaffolded support, like a secondary explanation or a related practice problem, ensuring the student achieves competency before the module advances. This web demonstrates the cascading benefits of that adaptive loop. By explicitly linking targeted intervention with immediate feedback, the system directly reinforces the retention and transfer of knowledge. Students remain engaged because the material is constantly adjusting to their proficiency. This immediate, localized feedback eliminates the post-mortem nature of traditional testing. Assessment functions as active, ongoing instruction that adapts to the learner's current understanding. Beyond assessment, generative models function as interactive simulation engines. They do not exist simply to output the correct answer to a static prompt. This graphic outlines the phases of critical thinking and creativity. Notice the cognitive shift from identifying a problem upward into testing and iterating novel solutions. An AI partner forces continuous iteration, injecting dynamic variables to push the learner toward the final objective, adapting to change. The sandbox creates a high-pressure environment where students must react instantly to shifting parameters. As the algorithm rebuilds the simulation's obstacles in real time, the learner is forced to adapt their strategy or fail. Building resilience and adaptability requires hands-on experimentation. Exposing students to these dynamic, generative problem sets is the only scalable method for preparing them to handle the volatile variables of real-world industries. It seems counterintuitive that a deterministic machine algorithm could cultivate subjective, human emotional intelligence. Yet this diagram shows how generative AI facilitates exactly that. By analyzing behavioral patterns and socio-emotional cues, these platforms act as safe, controlled environments to build skills like social engagement and emotional well-being. One documented mechanism for this is implicit bias reduction. Students use virtual reality to safely embody different personas, practicing conflict resolution with simulated avatars. This detailed communication data provides objective feedback, prompting the reflective practices shown in the framework that human observers miss. Mastery of social-emotional skills in these simulated environments produces a significant competitive advantage. As algorithms take over analytical logic, human empathy serves as the primary differentiator in the workforce. This leads directly to the macroeconomic reality outlined by AI job replacement theory. The core prediction of this theory is that artificial intelligence will fully absorb and automate lower-level mechanical and rule-based analytical tasks. This creates a paradoxical workforce outcome. As algorithms absorb analytical logic, the market demand for higher-order intuitive, collaborative, and creative skills surges steeply upward. The Gen AI pedagogy stack targets the specific cognitive skills, like iterative problem-solving and social intelligence, that remain insulated from automation. By simulating complex, real-world scenarios, the system provides the rigorous practice needed to master these high-value competencies. Integrating these models into the curriculum establishes the mandatory training ground for survival in the modern workforce. It provides the essential exposure required to master the collaborative and creative skills that algorithms cannot yet replicate. However, this architecture has severe structural vulnerabilities. If the algorithms ingest biased training data, that bias will directly corrupt the personalization engine, leading to skewed assessments and inequitable learning paths. Furthermore, sustaining a real-time adaptive ecosystem securely requires a massive initial investment. Institutions must navigate a heavy computational toll and strict data privacy regulations to protect the granular metrics being continuously collected from every student. In this new model, the role of the human educator completely shifts. Teachers move away from manual information delivery and take on the critical tasks of system governance, ethical oversight, and high-level mentorship. Generative AI provides the architectural infrastructure to sustain a lifelong learning ecosystem. It enables the entire institution to scale deep, individualized support in a way that was previously physically impossible.